Hello dear students, welcome to Pen and Paper Chemistry on YouTube.
Hello dear students, welcome to part 9 of the topic Thermodynamics. Up till part 8 you will find it on the channel
Pen and Paper Chemistry.
YouTube. Today we are extending our concept of enthalpy to various phase changes which take place. We're talking about the change from solid to liquid to gas. As always, we shall build on the concept or the fundamentals that you already know. So solid changing to liquid, you know that process takes place at a constant temperature. And because we've been talking about enthalpy, the standard enthalpy, so the pressure is 1 bar. 1 bar of pressure and a constant temperature because melting, evaporation, sublimation takes place at a constant temperature. Change of solid to liquid, known as melting or fusion, requires us to give it heat. In other words, this process is endothermic. Amount of heat that you require to change 1 mole of the solid into the liquid state at 1 bar pressure and constant temperature is what is called as the enthalpy or the standard enthalpy of fusion. This is denoted by the symbol delta H0F. F stands for fusion over here. The reverse process, that means liquid changing to solid, is called freezing. We said that when a solid changes to liquid, it's an endothermic process. That means heat is absorbed. Heat is absorbed means the delta H value that we get for this particular process would be positive when we are talking about the enthalpy change of fusion or melting. What about the reverse process? Here, you need to bring the particles closer to each other. In other words, heat will be given out because the particles are coming closer to each other, so heat will be given out. You need to cool it. That is why you need to cool it. So liquid changing to solid, delta H becomes negative. That means now it becomes an exothermic process. Same way for liquid to gas. Water changes into water vapor. Change of 1 mole of a liquid in standard state to gas at a constant temperature under 1 bar pressure is what we will call as melting. And the enthalpy change which takes place in this process is what we call as the enthalpy of vaporization or enthalpy of evaporation. The not sign indicates the standard state. The standard state of the reactant, pressure of 1 bar and a constant temperature. Obviously, the reverse process when you have to condense a gas form of a substance into the liquid. For example, you have to convert water vapor to liquid water. You need to cool it down because it will liberate heat. So this is an exothermic process, whereas liquid to gas is an endothermic process. Third, sublimation. Direct change of a solid to gas or vice versa is what we call as sublimation. Naphthalene, camphor, all these sublime. So both the processes are known as sublimation only. The enthalpy change, again, when 1 mole of the solid is changed to gas at 1 bar pressure, constant temperature in standard state is what we call as the enthalpy of sublimation. Now, to cut the long story short, what we've done over here is we write a general definition, remembering the 3 key points, 4 actually. 1 mole of the substance, 1 bar pressure, constant temperature, standard state. These 4 things we need to remember, and rest you simply need to fill in the blank. I want to define enthalpy of fusion. Enthalpy change when 1 mole of a solid changes to liquid at 1 bar pressure and constant temperature in standard states is what we call as enthalpy of fusion. Enthalpy of vaporization. Enthalpy change when 1 mole of a liquid changes to gas or vapor at 1 bar pressure and constant temperature in standard state is what we call as enthalpy of vaporization. Supposing you have to define enthalpy of condensation. Simply reverse. What do you put over here? For condensation, yes, gas changes to liquid and that will be called as enthalpy of condensation. Enthalpy of condensation is nothing but the same value as enthalpy of vaporization but with the opposite sign. Here it will be negative, here it will be positive. Enthalpy of sublimation, standard enthalpy of sublimation. So let me add the word standard over here so as to avoid confusion. 1 mole of a solid changes to gas at 1 bar pressure, constant temperature in standard state. So what happens is here you have 3 definitions compiled into one and you can easily define the other 2 as they are reverse processes. Coming to, and moreover these values, the delta H values, they are different for different types of substances. They are not the same. It depends upon the forces of attraction between the particles which decides how much amount of heat it will lose or it will require in order to change into the other phase. Coming to enthalpy of combustion. Combustion is nothing but burning of a substance in an excess supply of air or oxygen. Because I'm saying combustion, I'm not saying incomplete combustion. Let's define it as we have been defining others. Enthalpy change when 1 mole of a substance undergoes complete combustion at a fixed temperature, all substances being in their standard state. Now here, we will justify this definition with the help of 2 examples. Got carbon graphite combines with oxygen to give us carbon monoxide. Carbon in the form of graphite, oxygen gas, carbon monoxide gas. The delta H in this process is negative 110.53. This is the standard enthalpy. Let me put it as the delta H for the reaction. We've given another equation over here. Carbon in the form of graphite combining with oxygen gas giving us CO2 gas. The enthalpy, the standard enthalpy of this reaction is negative 393.5. See the definition, see the underlying terms and which of these will denote the enthalpy of combustion of carbon. Make a guess. And then we go on to discuss, because this is very, very essential when you do the numericals. Once this gets embedded, it will be very, very easy for you to handle the numericals involving combustion or anything. Enthalpy change when 1 mole of the substance. So let us see if I've got 1 mole of carbon. Yes. So this condition is satisfied in both the equations. Undergoes complete combustion. Now, if you notice, complete combustion of carbon should give us carbon dioxide. This is the lower oxide. Here, complete combustion of carbon has not taken place because carbon monoxide can be oxidized or burned further to give us carbon dioxide. So, formation of carbon monoxide from carbon in the form of graphite is not complete combustion. It is partial combustion. So, we cannot say, so this is on here, this condition is not satisfied. Fixed temperature, yes, all substances being in their standard state. That also we have to check. Graphite, graphite, gas, 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 gas. Supposing instead of graphite, I take any other form, let's say diamond or coal, whatever, then it will not be called as the standard enthalpy of combustion, even if it is giving us carbon dioxide. Now, enthalpy of combustion is always a negative value. If you notice over here, what does the negative value indicate for delta H? Yes, here delta H negative means heat is given out. Heat is liberated. It's an exothermic process. Always when a substance burns, heat is given out. That is why the delta H. So when we put the value of delta H theta over here, this also becomes the standard enthalpy of combustion of carbon as well. So I can write this value as the standard enthalpy of combustion of carbon or the standard enthalpy of this reaction as well. So you have to be very, very careful because this is where the trick in the numerical lies. Subscribe to
Pen and Paper Chemistry
on YouTube to keep yourself updated on the new videos that I shall be posting. We shall continue with the topic of thermodynamics. Let me know your views. Happy studying.
The only mission of this channel is to make learning chemistry easy and fun for all you students. With the help of the periodic table, the flowcharts, the graphs, diagrams, dealing with numericals, how to deal with numericals. And this can only happen when you keep a pen and notebook ready so that you can also take down notes for offline reference. There is no subscription to join the channel. There is no payment at all. Only request is to help spread a word about the channel by sharing it with friends, classmates, juniors, seniors, so that chemistry can be easy and fun for one and all. See you in the next video.